A car is moving along a horizontal road. A bob suspended from the roof of the car hangs at an angle of 4 degree with the vertical. Determine the acceleration of the car given that the acceleration due to gravity is 10 meter per second square. So we have the car roof and we have attached a bob and it is making an angle of 4 degree with the vertical. So that's a bob. So basically a weight, that's it. And this is your vertical and this is making an angle of 4 degree. So what are the forces acting on it? One is the gravity, your mg, and of course the tension force which is pulling it up. So it's better represent this way. So which is pulling it up. So this would be the tension force. Now, if you think about it, if I'm not told, this is in a car and all of that because of acceleration, right? This is happening because of inertia. I hope you guys understand this. The bob stays back when the object is accelerating. This happens only when there is acceleration. So the bob goes back by whatever angle it has gone back. It depends on the acceleration of the vehicle. If the vehicle accelerates, then the bob goes back. You guys can try this. Just take a thread, it's not very possible because the car itself keeps jerking and that is acceleration actually. It is possible. On a highway, I think you guys can try this any point of time, You guys, oh yeah, you guys are in 12th grade, so you can try. Okay, not 12th, whatever. So here, if I had not given that this is in the car and there's no acceleration, nothing, what would you have told? What is wrong with this diagram? A force which is pulling up to the right and a force which is pulling down. How can it make it move to the left? What does it mean? It means that there has to be an acceleration to the left. And this is your pseudo force. So we'll assume a pseudo force. We'll assume that there is a force. Okay. So this is your pseudo force. What is pseudo? Pseudo means false actually. The meaning of the word pseudo is false. So this is for your pencil. This is false force. Imaginary. Right? If I had just given this diagram and if I had given FP and this setup, then it would have made sense. Without that, it's not going to make sense. So with that understanding, since it is at this point, right? So as the bob is in equilibrium, not exactly actually, stationary. We can assume a pseudo force that acts opposite to direction of acceleration of the car, which helps us analyze the situation as a state of equilibrium. So applying Lami's theorem. So what do we have? We have one force, and one force. This is mg, this is fp, and we have this to be ft. So since this is 4 degree, then this has to be 4 degree. This is clearly 90. So this is 90. This has to be 180 minus 4 degree. And this would be 90 again. So 90 plus 4. Agree, guys? All this sounds okay? So now what to do? Just apply the formula and you're done, almost done. I understand that you feel that there's no values over there. So we'll see. So if I have to call this as something, mg by, I need not actually, sine 94 is equal to ng by sine 94 is equal to, this would be fp by sine 176 is equal to ft by 90 degree. Okay, so we are looking at fp because fp will lead us to the car's acceleration, right? As the bob is stationary, we can assume a pseudo force that acts opposite direction of the acceleration of the car, which helps us blah 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 blah, right? So basically we are looking at fp. So fp is equal to mg by sine 94 into sine 176. This is from first and second expression. Okay guys, fp is what? Pseudo force m into a. mg by all of this sine 94 into sine 176. So mg gets cancelled. Okay, so we basically have the acceleration, which is 10 times of sine 176 divided by sine 94. So this is around 0.699 meter per second square. Okay, so this from here we can imply the car is accelerating at a rate of 0.699 meter per second square. Okay, because we started off with our assumption that we are talking about a pseudo force, let that be fp, that acts opposite direction of acceleration of the car, right? This helps us analyze. Okay, you can put a full stop over here. This helps us analyze the situation as a state of equilibrium, applying Lami's theorem, so on and so forth. Okay, so analyze the situation as a state of equilibrium, and